Hello everyone. Today I'm going to talk about the encryption in Storm. And I'd like to start by talking about a paper named Big Data Analytics over encrypted datasets with CSAT. And it was published by the OSDI 2016 conference proceedings, and it's a very good work. So the background of this paper is business intelligence. Business intelligence comprises the strategies and technologies used by business for the data analysis of business information. Business information can be used by enterprises to support a wide range of business decisions, ranging from operational to strategic. The basic operating decisions include product positioning and pricing. However, storing sensitive business data on the cloud can raise privacy concerns, which is why many enterprises are reluctant to use cloud-based analytics solutions. These concerns can be mitigated by keeping the data in the cloud encrypted, so that a data leak would cause little or no damage. And the paper mentioned some exciting solutions like CryptDB, Monomy, and the trusted hard work. The first two solutions use deterministic encryption and are the homomorphic crypto systems. And the second one is trusted hardware. But these solutions have some drawbacks, like high computational cost or deterministic encryption is vulnerable to frequency attach. So this paper proposed two new encryption schemes, and the first one is adaptively symmetric homomorphic encryption, and the third one is spaceless. Is spade ASHE. And this simple picture shows the scenario they consider in this paper. The data collectors gathers a large amount of data, encrypts it, and upload it to an untrusted cloud platform. And analysts can issue queries to a query processor on the cloud. The responses will be encrypted, but the analysts can decrypt them with a secret key she shares with the data collector. So now we'll skip directly to the system design. This picture shows the major components of CBED. A user interacts with the CSED client proxy that runs in a trusted environment. The proxy interacts with the untrusted server. Untrusted server, and the CBED client-side proxy mainly use additive symmetric homomorphic encryption algorithm combined with spanned ASHE. We will mainly talk about the first algorithm, additive symmetric homomorphic encryption. Also, we implemented this algorithm in Storm, and I will show the implementation process later. And the homomorphic encryption is a form of encryption allowing one to perform calculations on encrypted data without decrypting it first. The result of the computation is in an encrypted form. When decrypted, the output is the same as if the operations had been performed on the unencrypted data. Here we see the encryption process of ASHE in detail. The trusted side encrypts the sensitive value in each row using the value minus a hash function and plus a hash function. When cloud computing aggregation on large data set, this result will be obtained, since the other values like fk1, and this is the minus fk1, and this is the plus fk1, and the result, when we get the sum result, this part will be cancelled out. It is possible to decrypt the sum of a range of values by evaluating the hash function only twice, regardless of the size of the range. The evaluation on real-world datasets shows that the ASHE algorithm is about an order of magnitude faster than existing technologies, and that its overhead compared to a plain text system does not exceed 45%. Now let's take a look at the implementation of this encryption algorithm in Storm. We use GitHub commit count data. We need to construct a topology. This is a simple topology. The spout reads the data and emit each tuple downstream. And the first boat receives the tuples and encrypts the sensitive value. like in this example, and the 4 and 6 and 5 is the sensitive value, and the user is not reluctant let the cloud know. So the first boot encrypt the value in like this. It's a safer text. And the counter boot, the counter boot counts the encrypted data and get a summer, which is an encrypted result. We use and so this the three nodes is the spot is read data, and the first boot is extract the data or the tuples and encrypt them, and the counter boot count the encrypted ciphertext, and we can get the get an encrypted result. So the and we just need to decrypt. We can get the result we want. And finally, so now we will take a look at the coding. First, we are going to look at the main entrance interface. It's a topology running. We use the new topology building function to initialize a new topology and allocate three nodes. This is the three nodes, one spot and two bots. And the spot the spot is perform read data. Performs read data. The spot reads the data from the text file and generate tuples and emit each tuple to the email extractor. This is the first boot, and the first boot received the tuples and encrypt them use this line of code. And when the boot encrypted the tuples, and then emits every tuple to the email counter bot. And the email counter bot performs addition on the ciphertext. And the ciphertext, after we run the program, the result is encrypted data. Now we take a look at the coding for decryption. Suppose that this line of numbers is the result we get. Now we go to run the decryption code. I just run the code. We can get the decrypted plain text. This is just a simple demonstration. In actual practical we need to submit the topology to a Storm cluster. That's all. Thank you for listening.